counting function. Okay, I think you can take note the term here in the slide. In the slide. Đấy, bạn ấy rất là cố gắng in slide ra nhé. Vì rất nhiều thứ định lý nó chuẩn rồi, mình có thể nguyên slide đỡ phải chắc hơn nhiều. Tập trung vào những ví dụ mà bài giảng phía ngoài thôi nhé. Ta hạn chế ghi cái này thì nếu mà ghi thì phải ghi hết không? Rất nhiều. Ghi chất này rất là nhiều. Nhưng cố gắng ghi chỉ là được. Okay, now we continue. Maybe you can use the slide right now. Okay, now if this is the graph function, continuous function. If the function f continuous on AB, then graph function f has no break EB, no break. Is that mean the graph is non-continuous, no break. Có điểm gãy, đứt gãy thì gọi là thì theo này liên tục, không được gãy nào thì gọi liên tục. The next term depends to the Weyer's chapter. If the function f continuous on AB, then it is bounded and obtain its minimum and maximum of AB. Obtain. Does that mean obtain? Does that mean achieve? Ở đây chữ obtain is the minimum and maximum. Does that mean exist two points f1 and f2 it belong to AB, such as f1 and f2, maximum and minimum function f on AB. Obtain is minimum and maximum on AB. Is that mean exist f1 and f2 it belong to AB, such as f1 less than the fx, less than the f2, form as belong to AB. Obtain is that mean exist f1 and f2 it belong to AB, such as f1, f2, minimum and maximum function f. Okay, đạt được giá trị lớn nhất và giá trị nhỏ nhất ở trên AB, tức là tồn tại hai cái này. Okay. So we went to the basic term, fundamental term. Let's f continuous on AB, then fx obtain on intermediate value between fa and ab. What does it mean? Now, you can see the function f a and b. Because the function f continuous function, so the function have no break. Okay, I think you know the value here is equal to the fa. The value here is equal to the fe. Obtain on intermediate value between fa and fe. What does it mean? You can see the y is right between fa and fe. We draw horizontal line. You can see the line here all the way intersect the graph function. Okay, all the way intersect because the graph function have no break. So horizontal line here all the way intersect. It may be if you can know this point by C. Is that mean y f1 and c? y equal mc. It doesn't mean the value function is contained interval of fi and fb. Okay? For all value, y is lie between all the way exit c. It belongs to ab. Y equal fc. Okay? We want to explain for this sentence. Okay. All value. Maybe you can ignore that. All value between fa and b. Fs. Now, based on three terms, we have the corollary, intermediate term, corollary, F1. Corollary, F1. Assume that f continuous on closed interval AB, then FA and FB have a product negative. Then the equation Fx always have at least one solution on AB. I think you know term in high school. I think you know that. F continuous, FA and FB negative. Okay, we can imply the function F have at least one solution on AB. I think you know. You know the theorem in high school? Bạn biết gì không nhỉ? Một hàm liên tục mà giá trị của nó trái dấu thì có nghĩa là giữa không?
Có.
Biết rồi đúng không? Có rồi chứ. Now, we have an example. We use the corollary here to prove example. Prove that the equation x to the power of 6 minus 4x plus 2 equals 0 has at least two roots the same solution. In the interval 0 to 2 solutions, two roots. How to check? How to check?
2
The example here we have the proof that
20 thay cho x bằng 0.
we have proof that
How
how to prove the equation here and at least two roots in the interval 0 1. How to prove that? Now, let's fx is equal x to the power 6 minus 4x plus 2. I think you know the function f here continuous on 0 to continuous.
Yes.
Not just f continuous on 0 to. Yeah. To continue, you can see the f0. What value?
2.
2. F1. F1. Negative 1. Okay, negative 1. You can see F0 times F1 negative. Negative.
Yes.
So, exit F1 it belongs to 0 1 success. F1 equals 0. The function f continuous on the interval 0, 1. The product here, negative. So the interval 0, 1 have the at least one solution. Yes? Exit the F1, it belongs F1 equals 0. To continue, F1 is equal negative 1. F2 is equal, okay, I think the positive.
Yes.
Okay, so the product here, negative. Negative, similar to the first. Okay, we can imply exit F2, it belongs to 1, 2, F2 equals 0. The same.
It's positive.
Exit F2, it belongs to 1, 2. Success F2, F2 0. Okay, I think you see the function f continuous on interval. F1, F2 has product negative. So the function f have the at least solution on interval 1, 2. To continue, you can see F1 it belongs to 0, 1. F2 it belongs to 1, 2. I think the two value here different. Two value here different. So we can enter here have the at least roots. Okay, at least two roots. This complete the root, the fruit. Okay, we finish the root for the circle. Okay, you can write out the rule for the example. Now, continue. We listen to the uniformly continuous linked together. Okay, we have the definition related to uniformly continuous on the set F. The function f is said to be uniformly continuous on f if and only if for all bar epsilon positive only exists the delta depends on bar epsilon positive such as for all f1 and f2 belong to f satisfies this condition. We have the absolute f1 and f2 less than pi epsilon. Uniformly continuous. Now, we return to definitions related to continuous function. You can see, recall, f continuous at f0 belong to f if and only if the limit here is equal f0. Equivalent to definition. For all bar epsilon positive always exist delta we can see delta depends on bar epsilon and epsilon positive success. Now you can see the difference between uniformly continuous and continuous with different. You can see uniformly continuous delta depends on bar epsilon. It's not epsilon. Continuous depends on epsilon. It's not the same. It's not the same. It's not the same. You have the example. In a change for uniformly continuous function and continuous function. In the example, we consider the function fn is equal 1 over x. We consider a function here on the set 0, 1, 0, 1. We can prove that the function f continuous on 0, 1, but not uniformly continuous on 0, 1. So, we have the difference between uniform continuity definition and continuity definition. It's not the same. The function is maybe continuous but not uniformly continuous. But if the function uniformly continuous, we can imply the function continuous. It's not the same. Okay? To continue, we have the property related to relationship between the continuous and uniformly continuous. You can see is the function f continuous on closed interval AB, then f uniformly continuous on closed interval AB. We have the relationship between two functions on closed interval AB. Closed interval AB. The property here you can use. Do the exercise. Okay, in the exercise we have some example using the theorem. We can apply the theorem to do some exercise. Okay, now continue. We must do the derivative. The derivative. Now, now. Derivative now. Okay, we have the definition of derivative of function. You can see the definition. Let f define on open interval AB. X0 it belongs to AB. Fx is said to have a derivative of X0 if the following limit here exists. When the limit here exists, we can denote the limit here by this form. We can reach f round x0. F round x0. Sometimes you call first order the derivative. Sometimes we can call first order the derivative.